So our last thing for this unit is solving rational equations. So far we've been dealing with expressions. We were adding them, subtracting them, multiplying, dividing, simplifying, finding our restrictions. So now what we're going to do is we're actually going to solve them. So here I just refresh our memories on what an expression is. So there is an expression. We have two fractions we're trying to combine. Over here is our rational equation. And you know it's an equation because it's got that equal sign there. So if you got fractions with that equal sign, that makes it an equation. So then you need to know to follow these rules. So a couple things to remember. A rational expression is undefined for any value of a variable that makes the denominator equal to a 0. We've been dealing with those. Those are our restrictions. So up until now, I kept telling you we're just practicing the skill, practicing the skill, practicing the skill. This is when our restrictions play a key part, is when you're actually going to solve equations. So we got to remember our restrictions. And then some answers to rational equations may cause a denominator in the problem to be equal to 0 and must therefore be rejected. So if we get an answer that was one of our restrictions, we have to reject it because that means it's going to create a 0. This is evident when you check your answers in the original fractions. You'll always see it in the original fractions. Solutions that do not satisfy the original equation are called extraneous. That just means they're solutions that when you do all your algebra work, you get the number, but when you actually plug it into the situation, it doesn't actually make any sense and it doesn't work. So for this example, extraneous solutions, if I factor this out, I would get x minus 2 times x plus 2. So therefore, my restrictions from this would be positive 2 and negative 2. And then for my other two fractions, I would still get positive 2 again, and then I'd get a negative 2 again. So our two extraneous solutions for that equation would be positive 2 and negative 2. So if we ended up giving those as answers, we'd have to reject them and then move forward from there. So we have two kinds of equations when it comes to our rational expressions. You have ones that are simply proportions. And your proportions are just simply one fraction equals one fraction. So if you just have it down to one fraction equals one fraction, you follow the proportions, which is you cross multiply, and then you solve for x, and then you check your restrictions to see if you have an extraneous answer. So for example, number 1, this is a proportion, because you have one fraction equals one fraction. That's how we know it's a proportion. So as I said, we are going to cross multiply. So that means I'm going to do 3 times the x minus 3. I'm going to multiply that top times the other bottom. And that's going to equal 2 times the x plus 1. I'm going to multiply the other tops and bottoms. So once we get this, we're going to distribute, solve for x. So that left side, I get 3x minus 9. Right side, I distribute my 2. And I get 2x plus 2. Let's get our x's together. So when I subtract my 2x over, I end up with x minus 9 equals 2. So in our last step, we'll add that 9 over. So I get x equals 11. So before I circle that and say that's my answer, I'm going to go back up here and check. If I put an 11 in for x in that first fraction, do I get a 0? No, so that's good. If I put 11 in for x over here, do I get a 0? Nope, I'd get an 8. So that works. I don't get any zeros in either of my denominators. So that's going to be our answer for that one. So two fractions is simply cross multiply. Now before we go on to the back, let's look quickly here. If you have more than two fractions, so if you have one that looks kind of like this example here, where we were looking for our extraneous roots. You have fraction plus a fraction equals a fraction. So we got more than just 2. What you have to do is you would follow these steps. You determine the least common denominator for all of your fractions. So you would look at all 3 of them, find your common denominator. Rewrite them with the common denominator, and then the rule is once all 3 of those have the same denominators, the denominator really doesn't matter anymore. You're just going to solve the numerators like a regular equation. So you cross out the denominators and then solve and check for extraneous roots. So let's go to the back and take a look. So when we have fractions written like these, a lot of people get kind of confused because they don't think it's the same thing as what we've been doing. So if we rewrite this, though, and just put the x in our numerators, a lot of times that makes it a lot easier for people to see. So let's go ahead and do that. So we'll put it as 5x over 8, 2x over 3, and then the x plus 7 over 12. That's not going to change. So we have denominators of 8, 3, and 12. So we got to find a common denominator between all 3 of those. So I always like to look. My largest one is 12. Well, can I make a 3 into a 12? Yeah, I can multiply it by 4. But could I make an 8 into a 12? No. So 12 is not going to be my common denominator. The next one would be 24. 12 can go into 24. Can 3 go into 24? Can 8 go into 24? Yeah. So I always use the largest one because that's going to make your life a little easier. 24 is going to be our common denominator. So I want to make all those 24s. So as we were doing before, what times 8 gives us 24? 3. So we got to multiply both top and bottom of that fraction by 3 to get an equivalent form of it, but over that common denominator. And then the 3 we would have to multiply it times 8. That would give me a 16x. And then that last fraction, what do we have to multiply by? 2. So we would get 2x plus 14 for that. So now, as I was saying on the front, now that all 3 of them have a common denominator, that common denominator really doesn't mean anything to us. So we can cross it out, and we simply have the equation 15x minus 16x equals 2x plus 14. You just solve your numerators. So on the left side, when I combine my x's, I would get a negative x, because 15 minus 16 gives us negative 1. Then what should we do? Yep, bring that 2x over. So I got negative 3x equals 14. We're going to get a fraction answer. Divide by negative 3. X equals negative 14 over 3. You want to leave that one as the fraction, because otherwise it's a repeating decimal. This is what they call the exact form. This is going to be your most accurate answer. So then if we go back and we take a look at our original fractions, we had an 8, a 3, and a 12. No variables there, so that means there's not going to be any restrictions. So our answer is going to work. All right, let's try another one. Number 3, we got fraction minus fraction equals fraction. So it's all written the way we want. We got a 7x, a 14, and a 2x. So again, let's look at our bigger number, 14. Can we make 7 turn into a 14? Yep. Can we make 2 turn into a 14? Yeah, so we're going to want to use 14. But 2 other fractions also have an x with it. So x is also going to have to be part of your common denominator. So 14x. So that first fraction has a 7x as its denominator currently. I need to make that 7 into a 14, so what I have to multiply by? 2. Which means I also have to multiply its top by 2. So I would get 2 plus 12x when I distribute my 2. Second fraction has 14. It's missing the x. So that's what I multiply by. So that would give me a 3x. And then our very last one has a denominator of 2x. What do I multiply 2 by to make it 14? 7. So there we go. So now all three of my fractions have the common denominator. I'm going to cross that out. And then I rewrite my numerators. That's my new equation now. That's what we're going to solve. So over here on the left, I'm going to combine my x's. So that 12x minus 3x gives me a 9x. So then I'll try to get my x's together first. So I'll subtract 7x. So I got 2 plus 2x equals 28. A lot of you are already ahead of me. Awesome. So we get x equals 13. So if I go back up and check, if I plug a 13 into any of those denominators, are we going to get a 0? No. So we can keep our answer, x equals 13. All right, last one in our notes. I'm first going to put that 2 over a 1, because remember that is a fraction. It is the fraction 2 over 1. And then I got a 3x plus 15. I can do a GCF factor there. What do they have in common? 3. I can pull out a 3, so I got 3 times x plus 5. So we can see here, this fraction and that first fraction both have an x plus 5 there. So that is part of our common denominator. This first fraction also has a 3. So since that's present in 1, that has to be in our common denominator also. Do we really need to worry about the 1? No, because 1 times 3, which would just be 3 again. So 3 times x plus 5. So that first fraction, already over that denominator we want, so the numerator is going to stay as 10x. I'm not going to change that. My next fraction has the x plus 5. It was missing the 3. So I'm going to multiply by 3. So that gives me a 12 in my numerator there. And then the last one, 4, didn't have really any parts of it. So I have to multiply that by the whole thing, 3 times x plus 5. So then the 2 times the 3 really gives us a what? 6. And if I distribute my 6, I get 6x plus 30. So 2 times 3 gave us a 6, distributed my 6 there. Now I get to cross out my denominators. I'm going to solve my numerators. Over here on the right side of the equal sign, I got those two numbers that I can combine. Gives me a 42. And we'll get our x's together. So what do we get? 42 divided by 4 gives us 10.5. So if I go back and check, will 10.5 give me a 0 in my denominator? Nope. If you look at this one, the only one that would be a -5. If I had gotten a -5, I'd have a 0. I can't have that. But I didn't get a -5.